10.2 Perimeter. Our learning intention: how do we calculate the perimeter of a variety of shapes? Our success criteria: I can calculate the perimeter of shapes, I can calculate the circumference of a circle, I can calculate the perimeter of composite shapes. So just a refresher on definitions. The perimeter is the total distance around the outside of a shape with 3 or more sides. So it doesn't matter whether it has 3, 7, 15, 28 sides, you add them all up together and you end up with your perimeter. The circumference is the total distance around the outside of a circle. So it's that solid line. When we've drawn a circle, it's pretty much how long is that circle or how long is that line. The diameter is the distance from one side of a circle to the other. Now with the diameter, however, it needs to pass through the centre point. And the radius is the distance from the middle of a circle to the outer edge. Now, going back to the diameter and the radius. Now, both of these pass through that centre point. Well, at least the radius starts there and the diameter passes through. The radius is actually half of the diameter. So if I was to just keep drawing that dotted line across here, I would end up with the diameter. And if I was to start at the centre there and put a line out there, I'm going to change colours so we can see the difference, and start at that same centre again and draw a line out there, I would have a radius, and I would have a second radius. So the diameter is equal to 2 times the radius, and the radius is equal to half of the diameter. So sometimes you'll be given the radius or the diameter and you need the other. Remember that the diameter is 2 times the radius and the radius is half of the diameter. Oh, a blank page. All right, so I'm going to draw a couple of shapes. This is my very drawn to scale rectangle. I've got a couple of lengths, I have a couple of widths, and my perimeter is the width, so my first width plus my second width plus my third width plus my fourth width. I add them all together and I've got 2 widths plus 2 lengths. I got my words confused. I was calling lengths widths and widths lengths. All right, but at the end of the day we have 2 widths and 2 lengths. Square, much the same concept. Imagine this is a right angled square, like it's all very symmetrical. Let's pop a few dashes there, and each is worth an L. So the perimeter of my square, just so that you know it's a square and it's not just a blob, the perimeter of my square is 4 times my length. Now, I can actually even find the perimeter of something like the end of the creek. Oops, that shouldn't have gone straight. The end of the creek, which I'll call 5 meters, the edge of the creek, then the fence over to it, that's 1 meter, that's 0.8, and we'll call that 4. If I added them all together, I would end up with 10.8 meters. Not a very, big yard, but I can add it up. It doesn't all have to be straight lines. It just has to be a line. So, on to composite shapes. Just a refresher on what a composite shape is. A composite shape is 2 shapes stuck together. And when I'm finding the perimeter of a shape, I don't have to factor in all sides. For example, with a rectangle, I only need to factor in 1, 2, 3 sides, and with the triangle, only the hypotenuse there and that base there. As you can see, I don't need to worry about this guy in the middle. Why? Because this is effectively 2 lines that are butted up against each other that are now no longer part of the outside of the shape. All right, so we get rid of them and we add up all the outside lines. Back to circles. So the circumference formula, let me just get rid of this guy so I've got room to scribble myself. There we go. I can show you step by step what to do. Make it skinny again or I'll be drawing all over my page. So the circumference formula and an example. The circumference of a circle can be calculated by using one of the following formulas. The circumference is equal to pi times the length of the diameter, or the circumference is equal to 2 times pi times the length of the radius. So C equals pi d, or C equals 2 pi r. Now remembering that your diameter is equal to 2r, so realistically the two C formulas are the same thing. I like working with the radius over the diameter. It's just a personal preference. You would have had it drilled into you throughout school. C equals 2 pi r, or C equals pi d. It's whatever you are comfortable using. At the end of the day, it's the same thing. So most of the time we're given, let me draw my circle, totally symmetrical. There we go. We're normally given the radius, which is that line from the centre, very straight. And we have to find the length of this guy on the outside, our C value. But in this instance, in this example, I'm giving you my C value and it's worth 100 centimetres, and you need to find the radius instead. Now it also indicates to 1 decimal place. Before we go too far, I'm jumping down to our exam hack. Always use the pi button on your calculator when calculating circumference. Be careful not to substitute the radius into the diameter formula, or the diameter into the radius formula. So don't get your D and your R value mixed up, is what it means. Jumping to my calculator, I've got a pi button. It's right on my bottom line and it looks like this guy here. The value of pi is 3.1415926. If you're only using 1 or 2 decimal places, generally if you've used a rounded off version of, it'll give you pretty much the same answer. But if you're needing to find something to 2, 3, 4, 5 decimal places, you need to use the exact value of pi. So try and avoid rounding it and use the actual button on your calculator. So back to our formula. We have C equals 2 pi r. Now, if I was to put my 100 in here, I'd have to then rearrange my formula to try and find my r value. But I'm going to rearrange the formula for you. So we have r is now equal to, oops, wrong thing, C divided by 2 pi. So I have the circumference, and all I need to do is substitute it into where my C value is, divide everything by 2 pi, and I get an R value. So R is equal to 100 over 2 pi. Now remember that over, or that fraction line, means divided by. And my answer is approximately 15.9 centimetres. I'll go and show you what to do on my calculator. Let's clear that. Do 100 divided by, now I need to divide it by 2 and by pi. So let's go divide it by 2, then divide it by this pi button. I get 15.915. If I was to round that to 3.14 instead of using the pi button, and I ask you find it to 3 decimal places, you'd end up with a completely different answer. Instead of the 15.915, you'd get 15.923, which if I was an assessor and it asked for 3 decimal places, I would be marking you wrong. So remember to use your pi button and not just substitute using 3.14. All right, next slide. The perimeter of a sector. All right, so we have this pizza. We need to share this pizza between 8 people. I'm now going to take one slice and I'm going to put it over a side here. That's my piece of pizza there. This piece of pizza, my piece of pizza, is called a sector. It's part of a whole, or part of a circle. A sector is the part of a circle formed by 2 radiuses and the part of the circumference of the circle connecting them. Sectors are like slices of a pizza where the cuts go exactly to the centre of the pizza. So I've drawn one down here. It's a little bit neater than mine. Let's grab my highlighter. A sector has 3 lengths around its perimeter, so we're still talking about those outside edges. 2 straight lengths that are equal to the radius of a circle. So we've got these guys here. And a curved length that is called the arc length, which is a fraction of the circle's circumference. There we go. All right, you can also see this little guy in the middle here. Oops, shouldn't have gone big. That guy there. He looks like a 0 with a little bit of a curved line through him. This is theta. When we were doing trigonometry, anything to do with relating to angles, we tend to use this guy theta to indicate the size of the angle. In most instances, you'll be given the angle. Sometimes you'll be given the arc length and the radiuses and need to find the angle. We'll take it one step at a time. All right, so how do we find the perimeter of a sector? Remember, this is my sector. I've got my R, my arc, and I've got my theta in the corner here. There we go. So first of all, we need to find the arc length. So we need to find that curved bit across the top. We use the formula arc length of a sector is equal to theta over 360 times pi times d. Remembering that d is equal to 2 times your radius, which we've got. We've got 2 radiuses on the outside. With the arc length, why do we use 360? Now remember that in a circle, there are 360 degrees. The whole way around the circle is 360 degrees. But we only need a snippet or a small portion of that, which is why we are dividing it up over here. And then add the arc length and the diameter. So D, remember D is 2 times your radius plus your arc length. Once we figure out the arc length, the rest is pretty crazy. All right, I'm going to see if I can chop this out. Take my formula with me. Nope, that won't work. Copy that onto my next screen and, whoops, paste him up there. Oh, he didn't work. All right. Anyway, I'll have to write him out by hand. Where's my pen? Arc length is equal to theta over 360 pi d. So my first step on calculating the perimeter of each sector. First step is to find my arc length. My arc length is theta over 360. So in this case, I've got 30 degrees. So that would be 30 over 360. Then I would times that by pi, and then I'd times that by my diameter. But in this case, I don't have a diameter. I do have a 14 centimeter radius. Remembering that my diameter is equal to 2 times my radius because I've got 2 sides. These little lines here indicate that the 2 sides are the same length. So D is equal to 2R, D is equal to 2 times 14, therefore my D value is equal to 28. So I'm going to put 28 down the bottom here and substitute that in. And then I pull out my calculator. So I do 30 divided by 360 times pi times 28. And I've got 7.33. Looks about right. So 7.33 centimetres. Hang on a minute, it's only wanting one decimal place, so let's cut one of those. 7.3 centimetres. Then I move on to step 2. And step 2 for this, we'll go back a screen, the diameter plus the arc length. So So my perimeter is equal to my arc plus my diameter. And I know that my arc length from the previous question is 7.3 centimetres. And my diameter, which I also calculated, was 28. Add them together, 35.3 centimetres. And that is, well, highlighters are better, the arc and both radius. Now part B gets a little bit trickier. Or question B gets trickier. Calculate the perimeter of each sector correct to 1 decimal place. Now I've got myself a radius and a radius. And I need to find my arc length around here. But I don't have a theta within the circle. So within here, I don't have a theta. I can, however, calculate theta. Going back to our circle is 360 degrees. And outside our circle, it's 75 degrees. So I'm going to subtract 75 degrees. It should give me 285 degrees. Let's just double check that. 360, subtracting 75, 285 degrees. So my theta value is equal to 280 degrees. Using exactly the same formulas as before, I'll find my arc, which is my pink line there, is equal to 285 divided by 360 times pi times my d value. My r is 23.6 and d is equal to 2 times my r, which is 2 times 23.6, which is equal to 47.2. Yeah, cool. I am just double checking all these as well. 47.2. All right, so back to this calculator. We've got 285, clear it, 285 divided by my 360 times pi times 47.2. And I get an arc length of 117.39 equals 117.39 centimetres. Now, again, it asks me to 1 correct decimal place, so that becomes 117.4. Now I add everything up, and I've got my perimeter is equal to my arc length plus my diameter, which is 117.4 plus 47.2, which is 164.6. Oh, don't forget my unit of measure. Oops, we're in millimetres. What am I doing? We're in millimetres. I've marked that up. All right, so 117.4 plus 47.2 gives me 164.60. Again, they should be, let me get rid of that, should be millimetres. If you don't provide the unit of measure or provide an incorrect unit of measure, you will tend to lose half a mark or so. All right, that is the end of perimeter. Stay tuned for area.